Now, from now, I am also going to do some of the question series for electrical engineers. This will be useful for all the JEE exams and also for Telangana SPDCL exam, which is coming very soon. Sub-engineer exam as well as AE exam. Questions are substandard, but they are universal. They are valid everywhere for all the PSU exams other than GATE. For IES exam also they can be used. So please have a look at these questions. Right. Now let us see the first question. In PNP transistor, the configuration forward biased emitter based junction, and reverse biased collector based junction is known as. So he is asking in a transistor, he gave the conditions forward biased and reverse biased, and he is asking the corresponding mode of operation of transistor. So let us write that. Let us write the modes first. So emitter base junction, collector base junction. There are two junctions, emitter base and collector base. Then mode of operation and application. Right. If both the junctions are forward biased, if emitter base and collector base are forward biased, then we call this mode as saturation mode. And it acts as a on switch actually. Right, like this, on switch. Now, if these both are reverse biased, I mean emitter bias and collector bias are both are reverse biased, then it acts in cutoff mode. So we can say this is just like an off switch. Like this. Now, if emitter base junction is forward biased and collector base junction is reverse biased, then we can say this as active mode or forward active. And here the application of transistor will be amplifier. Most of the transistors will be operating in this mode only. Most of the transistors will be operating here itself. And the major application of this mode is amplifier. Amplifier means it increases the strength of a weak signal. Suppose if you give a weak signal, it will increase the strength of a weak signal and send it to a strong signal, strong output. Right. Now coming to the last mode. If emitter base junction is reverse biased and collector base junction is forward biased, this mode is called inverse active mode. This is rarely used actually. So this can be used in an attenuator. This mode is used in an attenuator. These are the four modes, and we got the question that forward biased emitter base junction and reverse biased collector base junction. So this is the mode. So answer is active mode, right? Where is forward active, right? This is the option. Option B is correct. Now please remember this table, because in future we are unable to guess which is coming. Now it was asked regarding forward active, but we cannot guess if they can ask saturation or cutoff. Right? There are chances of asking them also. So please remember this table. Now let us go to the second question. Which one of the following portable device is used for measuring the insulation resistance of a circuit? Instead of circuit, it's better if you write a cable. Insulation resistance of a cable. Then our circuit also not an issue. Insulating resistance is very, very high resistance. It comes under very high resistance. That means greater than 100 kilo ohm. Generally it will be in the order of mega ohms actually. Insulation resistance of any cable or circuit will be in the order of mega ohms actually. Right. Now see the options. Ammeter. Ammeter is used for measuring insulation resistance. Wrong, because ammeter is used for measuring current. Next, voltmeter. Voltmeter is used for measuring voltage. And next, Megger. Let's see this option later on. Let's see what is this. Wattmeter. Wattmeter is generally used for measuring power. Right. So the remaining option is Megger. This Megger will be used for measuring insulation resistance. right? There are three types of resistance, we all know. Types of resistance: low, medium, high. Fine. Low will have till 1 kilo ohm. Less than 1 kilo ohm will come under low resistance. Right. Let me write this. Once let me write this. Okay, this is not working. Why is wait. Ah, fine. Less than 1 kilo ohm. And this is 1 kilo ohm to 100 kilo ohm. And high resistance will be of the order greater than 100 kilo ohm. And there are some methods for analyzing this. I will write first for high resistance. What are the methods? Loss of charge. This is creating problem today. This is creating problem for me today. Okay. Loss of charge method, direct deflection method, and the third thing is Megger. These three are used for measuring high resistance. Now, let us come to medium resistance. For medium resistance, there are meter voltmeter method, ohm meter method, substitution method, and Wheatstone bridge method. And these four are used for measuring medium resistance. Now, coming to low resistance. Kelvin's double bridge method, and potentiometer, and the third thing is we can sometimes use ammeter voltmeter method here also, right? We can use here as well as here. So these are the classification of types of classification of resistances and their ranges and the methods which are used to measure the respective resistances, right? So the correct answer will be Megger because it is given as insulation resistance and insulation resistance will be in the order of mega ohm and none of the other options are matching. Fine. Let us see the third question. An alternator with 10 pole, okay, 10 pole is running at 120 rpm. He gave the speed also. Frequency of produced voltage and current is, okay, fine, it is very simple. Generally, for synchronous speed, we have the formula n is equal to 120 f by p. Alternator speed is given 120 rpm and 120 into f he asked. And he asked for, he gave the number of poles as 10 pole. Fine, done. 120, 120 gets cancelled. Answer is 10H. Done. None of the other options are correct. Done. Simple. Now, let us see the next question. The half wave rectifier can be designed by using a minimum of. Fine. There are three types of rectifier. Diode rectifiers. Half wave center tapped rectifier, it is called M2. Center tapped rectifier is called M2 in shortcut. Bridge rectifier is called P2. Half wave rectifier will be having one diode. Minimum of one diode is needed. For center tapped we need 2, and whereas for bridge we need 4. So the correct answer will be 1 PN diode. The half wave rectifier can be designed by using minimum of 1 PN diode. This is enough. This is for center tapped. And 4 is for bridge. 3 PN diodes is for 3-phase half wave. For that we need 3. Fine. Done. There is one more important table. Actually, I am not able to write the table as we have limited time. So there is one more table corresponding to the comparison of diode rectifiers, like ripple factor, efficiency, etc., etc. There are some, there is one broad table actually. Please don't forget to revise the table while you go to any exam, because there are more chances of asking those tables, right? Thank you. Next question. Core loss is equals to, okay, fine. Okay. What is the sum of core loss? He is asking. Core loss is made up of, generally core loss is made up of hysteresis loss and eddy current loss. This is the thing. There is no other loss involved in core loss. So eddy minus hysteresis wrong. Eddy plus hysteresis right. Eddy mechanical copper, no way. Copper is separate actually. Eddy minus hysteresis wrong. So we can go for eddy current loss plus hysteresis loss. It is valid everywhere. In every rotating machine, core loss is equal to sum of hysteresis loss as well as eddy current loss. That's it. Fine. The resultant material after doping a germanium or silicon with boron. Okay. So generally there are two types of semiconductors. The first case is intrinsic semiconductor and the second case is extrinsic semiconductor. Fine. In the intrinsic semiconductor, this is the purest form of semiconductor. But when intrinsic semiconductor is doped, if it is mixed with some agents, some impurities, then we get extrinsic semiconductor. And extrinsic semiconductors are two types actually, P type and N type. Fine. Then he is asking the resultant material after doping a germanium or silicon. Means initially it was germanium or silicon or in intrinsic semiconductor, and when it is doped with boron, now the doping agent should be either P type or N type. Here doping agent is boron. So let us write the examples for P type and N type first. Examples of P type are, the first one is out: boron, indium, aluminum, gallium. Fine. For N type it is phosphorus, arsenic, antimony. Antimony will be different with symbols. It is called stibium. Its Latin name is stibium. Fine. These are the options. He has given the resultant material after doping a germanium or silicon with the boron. So we are adding a P type impurity. So we will be getting P type semiconductor. That's it. Done. So if he adds any of these like phosphorus or arsenic or antimony, then we will be getting N type. These are not valid, not needed. In an electric circuit, conductance is analogous to dash in a magnetic. Okay. So he is comparing, that's it. Electrical circuit as well as magnetic circuit he is trying to compare. So generally in electric circuit current will be flowing, and in magnetic circuits flux will be there. And here we will be applying voltage or EMF or whatever. Here we will be having MMF. And here opposition offered to the flow of current is resistance. Here opposition offered to the flow of flux, magnetic flux, is reluctance. Then support, the support offered to the flow of electric current is nothing but conductance. Fine. And here it is the support offered to the flow of, I mean the ease with which the electric flux flows through the magnetic circuit is what we call this permeance. Right? It is conductance and it is permeance. That's it. Resistance and all, you know, this is reluctance, this is voltage. If it is voltage or EMF, it is MMF, it is current and it is flux. This is the comparison, basic comparison. In electric circuit, conductance is analogous to permeance. That's it. Reluctance, for reluctance it is analogous to resistance. Done. For constant input, okay, the curve showing the variation of armature current with its field current, okay, armature current versus field current is called, in a synchronous motor is known as which of the following curve? Okay, fine. So there are two curves in synchronous motor. The first curve is between armature current versus field current, and the second curve is between field curve versus power factor. So we call the first curve as V curve, and the second curve is known as inverted V curve. Inverted V. So we can write it as like this. So the answer is V curve. Done. Which one of the following is incorrect? Resistance is directly proportional to the area of cross section of conductor. Resistance is inversely proportional to the area of cross section of conductor. Resistance is directly proportional to the length of conductor. Resistance depends upon the nature of material. So he is asking for incorrect statement. So let us write the laws of resistance first. So laws of resistance. So in the laws of resistance, first law is resistance is proportional to length of the conductor. And the second law is resistance is inversely proportional to area of cross section of conductor. It depends upon the resistance, depends upon the nature of material, and resistance depends upon the temperature also. So if we combine both of this, it will be rho R proportional to L by A. If we remove this proportionality and if we add a constant, it will be rho L by A. This is the resistance formula. So here he is asking which of the following statement is incorrect. So see the first statement. Resistance is directly proportional to area of cross section, but we got this as like this. But here it is inversely proportional. So incorrect statement. Incorrect. Next, inversely proportional. Resistance is inversely proportional to area of cross section. So correct. Resistance is directly proportional to length. So correct. And the fourth one is the resistance depends upon the nature of material. We already wrote that thing. So this is also correct. So the correct answer is option A, which says resistance is directly. So since he asked for which of the following is incorrect. If he have asked for which of the following statement is correct, then 2, 3, 4, B, C, D, all are correct. Fine. Let's move to the next question. The generated EMF in DC generator is, okay. Again he is asking the same relation type question. So generated EMF formula is pi NZP by 60A, where phi is called flux per pole in Weber or milliweber, whatever it may be. N is speed in RPM. Z is conductors, armature number of armature conductors, and P is poles, number of poles. A is armature parallel paths. So for lap it will be A equal to P, and for wave A equal to 2. This is simplex lap and simplex wave. Please do remember, this is for simplex lap and simplex wave, not for duplex or triplex. Right? Now he asked which of the following may be right. The generated EMF in DC generator is directly proportional to, or let me write the equation again. Pi NZP by 60A. Directly proportional to number of parallel paths, but inversely proportional. Directly proportional to flux per pole, correct, because Eg is proportional to pi, correct. Next, inversely proportional to A armature rotation, but here it is directly proportional, and last statement is inversely proportional to number of generated poles, but here it is directly proportional. So the answer is B. Obviously B is right. Next, which of the following is correct for n-type semiconductor? For n-type semiconductor, which of the following? Okay, majority carrier minority. Okay. Let me write this. Let me write for p-type, n-type. Majority carrier, minority carrier. So for p-type, majority carriers are holes. For minority carriers are electrons. For n-type, majority carriers are electrons and minority carriers are holes. So let's see the options now. Electrons are called majority carriers, right? Electrons are called majority carriers, right? Then holes are called majority carriers. No, because holes are called minority carriers for n-type. The electrons are called the minority carriers. No chance, because we already got correct answer. Both holes and electrons are called no way this is correct. So the correct answer is option A. That is, electrons are called majority carriers, whereas holes are called minority carriers in n-type. But if he gives for p-type, then we can say that holes are majority carriers and electrons are minority carriers. Next, he gave some question. He gave some figure and he gave inductance L1 equal to L2 equal to 2 Henry. M is mutual inductance and K is the coefficient of coupling between the coils. Okay. Coefficient of coupling is given. Then he is asking. He is asking the relation between. He gave M is mutual inductance, K is coefficient of coupling between two coils. Then he is asking the relation between M and K. Okay, fine. Let us write. We know the formula for coefficient of coupling is K equal to M by root L1 L2. Done. We are done. So K equal to M by root L1 L2. Root 2 into root 2. So it will be M by 2. Therefore, we can write M equal to 2K or K equal to M by 2. See the option. M equal to 2K. Option C is right. Option C is correct. Fine. The two similar parallelly connected inductor coils have inductances of 10 Henry each and mutual inductance between them is 2 Henry. Then the value of equivalent inductance is. So he is saying parallelly connected inductors. So equivalent of parallelly connected inductor will be L1 L2 minus M square divided by L1 L2 plus or minus 2M, where plus is for parallel opposing, minus is for aiding connection. So he didn't mention whether it is aiding or opposing. So we have to find both the cases here. L1 L2 10 into 10 minus M square 2 square 4 by L1 plus L2 plus or minus 2M 2 into 2. Then 100 minus 4 96 divided by 20 plus or minus 4. Two cases will be coming here. 96 by 20 plus 4, 96 by 20 minus 4. So it will be 4 Henry. Equivalent inductance will be 4 Henry and equivalent inductance will be, let me draw the figure also. Like this. There might be two cases depending upon the connection actually. 10 Henry, 10 Henry. He didn't give whether it is the opposing connection or supporting connection. I think it will be 6 Henry, 16, 6 and 96. Okay, fine. So these are the two possible cases of inductance, equivalent inductance. Fine. Okay, fine. A residence is connected to load having two 20 watt lamps. So two 20 watt lamp. So it will be 40 watt. Total will be 40 watt. Then 10 60 watt lamp. 10 60 watt lamp. So it will be 600 watt. Okay, fine. Then 500 watt lamp. 5 into 100 watt. So it will be 500 watt. Then and 6 10 watt lamp. So it will be 60 watt. Okay, fine. The demand meter indicates a 30 minutes maximum demand of. So he gave maximum demand as 600. Then he asked demand factor. Okay, fine. So we did correct only. So demand factor will be maximum demand by connected load. So connected load will be sum of all these, right? All these loads are connected. So we multiplied all the, we find the entire rating and we are going to add it now. So it will be around 1200. So now maximum demand is 600 divided by 1200. So the answer will be 0.5. Done. So demand factor is always less than 1 and hence it is proved. The only factor which is greater than 1 is diversity factor. Diversity factor is greater than 1 always. Only this thing will be greater than 1. Remaining all will be less than 1. So don't get confused please. Now the instruments which directly indicate the instantaneous value of an electrical quantity at the time when it is being measured. Okay, directly indicate the instantaneous value. Which indicate the value directly are called indicating instrument, that's it. Integrating instruments are like our energy meters. They will integrate all the readings in a month over a period of time and they will give the reading at a time. And recording instrument, these are not needed. These are like seismograph and all, which measure the earthquake quantity, etc. Recording voltmeter, seismograph, etc. So these are not given. The question is asked regarding the indicating meters, that's it. These are secondary instruments actually. There are two types of instruments, absolute and secondary. Secondary instruments are further classified as like this: indicating, integrating and recording. So indicating instruments are these instruments which give the quantity of to be measured directly like an instantaneous value, right? Whereas integrating instruments will integrate all the, which they will collectively add the sum of all the readings which they got in the over the period of time. And recording instrument case is completely different. These will have an example of that seismograph only. Fine. Okay. Again we got power system question. In a power station, the maximum demands of 6 elements of a load are observed as from maximum demand meters are he gave 6 readings, individual maximum demands. Maybe he might have asked for diversity factor. I thought maximum demand of the whole group as observed the maximum demand meter is 1000 watt. Okay, I understood. So diversity factor. Diversity factor is sum of individual maximum demands. Sum of individual maximum demand divided by maximum demand of station. So sum of individual maximum demands. Add all these. 1110. So let me add 600 plus 510 plus 420 plus 360 plus 100 plus 510. So the answer will be around 2, 9, 10. 11, 15 plus 2, 70, 70 plus 8, 25, 2500 watt. So it will be 2500 watt. Sum of individual maximum demand is 2500 watt divided by maximum demand of station is 1000. So the answer is 2.5. As I said earlier, maximum diversity factor will be greater than 1 and here it is done. Very simple. Very simple. The limiting point or critical temperature above which ferromagnetic material become paramagnetic. Okay, fine. Ferromagnetic material will be becoming paramagnetic material by losing all its magnetic properties. Above which temperature? That point, that critical point is called Curie point actually. It is a definition. It is very, very important for all the PSU exams. It is called Curie point. Boiling point, melting point are not needed. Not needed. So Curie point is the answer. Next, in the figure, each capacitor has a capacitance of 1 farad. Then equivalent capacitor. Okay, fine. This is very simple. These two. Once I will apply some voltage source or current source here. The current starts coming here. Now, at this point, current starts dividing, right? So wherever the current starts dividing, then we can say that both are parallel. So here these two are parallel, right? So equivalent in parallel connection, capacitance, equivalent capacitance is C1 plus C2, simply adding. So it will be like this. So this will be 1 farad and 1 plus 1. So it will be 2 farad. C equivalent. So current again is coming. Directly it will go. I is coming. So same current is there in the entire circuit. So we can say that both the capacitors are connected in series. Fine. Here it is divided. So we called wherever current divides, then we can say that they are connected in parallel. But wherever the current is equal all over the circuit, then we can say that both are connected in series. So in series connection of capacitors, we can say that equivalent capacitor is C1 C2 by C1 plus C2. Done. We are done. So C equivalent will be 1 into 2 divided by 1 plus 2. The answer will be 2 by 3 farad. So equivalent capacitance is 2 by 3 farad. Done. We are done. Here also I will write. Done. No. Okay. Two coils having self-inductance of 10 and 15 are connected in series aiding connection. Series aiding connection. Find total inductance if the mutual inductance is 2.5. Okay, right. Let me write the question. L1, L2, 10 Henry, 15 Henry, I remember. 10 Henry and 15 Henry. Okay, fine. And M is given as 2.5 Henry. So, he gave series aiding connection. So, for series aiding, the formula will be, equivalent inductance formula will be L1 plus L2 plus 2M. And series opposing will have equivalent inductance as L1 plus L2 minus 2M. So he gave aiding, no? So we can add directly L1 plus L2 plus 2 times of M. So the answer will be 25 plus 5. So the answer will be 30 Henry. The answer will be 30 Henry. If we have asked for series opposing, then it will be 10 plus 15 minus 2 into 2.5. The answer will be 20 Henry. Where is the answer? Any option? No. 20 Henry for series opposing. Similarly, you can find for parallel aiding, parallel opposing also. I'll write the formula here. Parallel aiding. I already wrote, but I am writing again. L1 L2 minus M square divided by L1 plus L2 minus 2M. For parallel opposing, L equivalent is L1 L2 minus M square divided by L1 plus L2 plus 2M. These are the two things to be remembered. Here it is 2 and here it is 2. Series aiding, series opposing, parallel aiding, parallel opposing. These are the formulae. If you want, you can substitute here also and you can check whether any of the options are matching. Now, a string insulator has 4 units. The voltage across the bottommost unit is 33.33% of the whole. Okay, fine. Find the string efficiency. Okay. He is saying that there are 4 units actually. There are 4 units of discs. Like this. There are 4 units. And he is saying that voltage across the bottommost unit, whichever it is, bottommost unit V4, let me consider that V4 is 33.33% of the total voltage. Fine. So we can modify this as 0.3333V, right? V4 is 0.3333V. Then he asked for string efficiency. Okay, fine. Very simple. String efficiency formula is voltage across whole string divided by total voltage. Here it is V, right? That's why we got 0.33 times of V. And string efficiency is defined as voltage across whole string divided by number of strings into number of insulators into voltage across the bottommost unit, or voltage across the insulator, voltage across the insulator disc which is nearest to conductor, or this can directly be written as voltage across the bottommost unit also, because that bottommost unit will be very near to conductor. So he gave like this. Voltage across whole string is V and he has 4 units, right? He gave 4 units into, and voltage across the insulator disc which is nearest to conductor. So this is 0.3333 times of V. If we simplify this, it will be 1 by 4 into 0.3333. If you add percentage, then multiply with 100. multiply with 100. So 1 by 0.3333, I think if you simplify this, you will be getting 75% directly. This is previous IES question actually. I added here. So answer will be 75%. This is the way of solving. This is the formula to be remembered. I think for ECET 2021 it was asked, and for some PSU exams also it was asked. AP ECET 2021 it was asked, I think. As far as I remember, this was previous IES question also. While teaching for my students, offline students and online students, I taught this question. Now I got a chance to teach this on YouTube also. Right? Let me see the next question. Okay, fine. The questions got completed. I think I solved 20 questions now. Let us see some more questions in the next possible session. And please, if you like this session, please make me motivate so that I can do more sessions. For motivating me, what you have to do is please share this session, like this session, comment something. If you have any doubt or if it is if it is good or bad, please comment so that we will be understanding what is the case and we will try to improve if there is improvement needed. But I need maximum number of shares and maximum number of views so that I will get motivated myself, that people are interested to march, so that I can do more number of videos like this. More interesting videos are yet to be coming. If you support me, I am going to do more number of videos. Right? Thank you.